Hello everyone. My name is John Sayer, Technical Marketing Manager, Civil Infrastructure here at Autodesk. Today I would like to walk you through the second part of the Scan to BIM workflow. We will walk through the drone to design workflow. This process will start off by taking a look at photogrammetry from a drone and processing it through Recap Photo. Next, after processing has finished, we will bring the process data into InfraWorks and create an existing ground topo and utilize the georeferenced what is there today image so that we can start with planning our proposed site or sites. Then we will bring the information into Civil 3D where we can start to take a look at design. So let's get started. First, let's talk about the project. We've been contacted by a client and they need an existing ground topo to start planning for a large project. This site is around 200 acres and would take days to traditionally survey. By capturing the existing conditions with a drone, we're able to collect the data we need in the field in 2 hours instead of 2 to 3 days. And I'm being generous with the 2 to 3 days. We will also apply GCPs or ground control points to improve the accuracy of our aerial survey, and I will show you the results at the end of the video. First, let's talk about the imagery itself. I want to show you real quick what is on the image itself when the drone takes the photo so that you can understand how it's getting its coordinates. So I'm just going to bring over here just one of my photos. I'm going to double click on it. And this is the photo itself. So it just looks like a regular a picture that was just taken from a camera. And it is just a picture that was taken from a camera. It's just taken from a camera on a drone. This drone was a DJI Phantom 4 Pro, and it's got a 20 megapixel camera with a 1-inch sensor. So it's a very good quality camera, and it does a very fine job for what we're going to use it for today. So let's look at the properties real quick of that same image. So if I look at the properties itself of the image, I can look under details and I can see what type of drone actually flew it. Actually, if I drop down here, I can see that the camera maker. So the camera maker in this particular instance was a DJI. So it was a DJI drone. It tells you the dimensions and the resolution and that of the image itself. But what we're really concerned with is this right here, the GPS coordinates. So it actually embeds a lat long and altitude of the photo of that onto that photo itself. So this is how Recap Photo takes and stitches these photos together with the help of GCPs, which are ground control points. So I thought it'd be best to start here and explain how and why these images are able to be referenced, and then it might make a little more sense later on when everything gets put together. So it's very simple to build a model inside of Recap Photo. We simply go up to Aerial here under Create 3D, and then we can either select anywhere here on the screen or we can hit Add Photos. So if I pick anywhere on the screen, it's going to bring up my Open File dialog box just like it does here if I hit Add Photos. So in this particular instance, I've got two different folders that have, let's see how many images we have. We have 793 files. All right. So I can add them one at a time. So I can double click on the first folder. And I'm just going to pick the first image, scroll down, use my Shift key to mass select and hit open. And that'll add the images to the project. Now while those are loading, I can go back over and I can add more photos. So we had two folders there, so I'm going to go ahead and double click on the second folder and add the rest of the images. All right. Now we took some additional shots on a hotel that was down around in that area that was already built, and we wanted to model it a little bit closer than just doing like a mow the lawn type mission or even a crosshatch mission. So we took some additional shots on that La Quinta. So those shots are called obliques. So we took some oblique shots that were pretty close so that we could get good images of the facade of that building. So I'm going to go ahead and add those in. I'm just going to pick, I don't have to pick them all. I'm just going to pick that group right there. All right, so I'll have to add the photos in. So I'm going to select Add Photos. And I'll scroll back to my Lakita folder, and I'll select the images that I want to add. Now you can see I'm already at 971 photos in this particular project. Recap Photo has a 1,000 photo limit, so I want to be sure not to go over that 1,000 photo mark. If I do, it's okay. I can just delete the ones out that I don't think I need. In this particular instance, I'm just going to bring in the images that were flown close so that I could capture the facade of that building. So I'm just going to grab that many and hit open. So it says duplicate file names were found. So if I click cancel, it cancels the operation. We don't want to do that. If I click no, it adds non-duplicate files only. And then click yes to override existing files. I don't want to override any of the existing files. So I'm just going to hit no, and it's going to add those files in that are non-duplicate. And I can scroll down here to the bottom after that's done and look and see if I've got everything I need. If I don't have everything I need, then I will have to go back and actually rename the files that I want to put in there. And you can just do that by putting an additive to them inside of Windows Explorer. So now that I've got my images, the next thing to do is to add GCPs, or ground control points. So I'm going to select ground control points. And I'm going to make sure that my coordinate system is set correctly. So it should be set to MO83-CF. Notice that you do have all of the coordinate systems that you're used to seeing in Civil 3D, InfraWorks, Navisworks, any of the other parts of the AEC collection. The coordinate system should match up. So I do know, like I said, that this is MO83-CF, so I'll just hit OK. All right. And then I need to add my GCPs. So my GCPs, I've got those right here in a notepad file. Just has a point number, the easting, northing, and Z elevation. Now that matches here and will match up to GCP names, so point number 1, XYZ, which is easting, northing, and Z elevation. All right, that's what we want to try and match up. So I'm just going to simply select all of them and copy, pick over here inside of this box and hit Control V, and it will paste those GCPs in. So there's a couple different ways that we can kind of get to know where these GCPs are inside a recap photo, because we might not necessarily have been out on site when these GCPs were collected, or we may not have been the person that flew the site, but we do have maybe these points imported into Civil 3D and we can look at them with an image underneath. Or if we select like point number 1 here and we look at these images and make sure that this is selected, filter by GPS, I know that this particular point number 1 is actually a manhole lid. All right, so I know that by selecting point number 1, it's going to give me the images just for point number 1 or around where that GCP was collected. So I'm going to select this first image. All right, and I know because I actually was out and set these ground control points, kind of where this particular manhole is at, and there's several manholes that you can actually see here inside of the image. But this particular GCP is this manhole right here. So I can zoom in and I can stick a point right on that manhole. Now, if I want to get it closer, I can zoom in here and I can move this to get it right in the center of the manhole. Once I've done that, it tells me that I need to place GCPs on at least 3 more images. So I select that button and it brings up the rest of the images that are close to that location. So I'll just go to the next one and I'll zoom in, and it's this same manhole right here. You can kind of get oriented as to what other features are out there. All right, this inlet, this drainage area right here, this building, this parking lot, so on and so forth. So I'm going to go ahead and select that manhole again. And again, I could zoom in, move this to the center of the manhole, hit done. And now I have one of, that is actually showing me here, 1 of 2 of the GCPs. So I need 4. 4 is the magic number when you're setting images to a GCP. You want to have at least enough overlap to cover 4 images with the GCP. So I can go ahead and select this image here because I know it's going to be good to go. So that manhole is right here. So I'll zoom on in and I'll pick close to the center there and I'll move it here. Hit done. And then I need to pick one more image. So I can pick any of these. Now, if I pick one and don't see it, which I don't, actually, that is the manhole, but it's pretty far up in the image. I want to have enough coverage in the images that the GCP is around, closer to the middle. You can, in a pinch, you can add it wherever you'd like, and it shouldn't make any difference in the stitching of the imagery, but I just like, for good measure, to have plenty of coverage with the images. So I'm going to select this image here, and I'll go ahead and I'll pick that manhole again, and that will be my fourth GCP. So I'll hit done. Another way that we could see where our images are that affect each GCP is we could go up and select map. All right. So when we select map, it gives us a map of where all of our images are at and where all of our GCPs are. So you can see there are several GCPs in this particular project. It's covering 200 acres, so there needs to be several. So we've got 23 to choose from here. We don't have to use them all, but it's probably good practice to use as many as you can. So I would just find GCP number 2, and there it is. And I can zoom in, and I can see the images around it. Now this particular GCP is a parking stripe, but it's the parking stripe right here. Okay, this is just a go-by image as to it's close to where it would be located in the field, but you're going to be able to locate it definitely whenever you select one of these images. So the image that I could start with is 0742. So I can go back to photo, and I can find image 0742. All right, and that image is right here. All right, I can select it, and I can see very, very well the definition of these parking stripes. So that GCP is actually right here. It was taken at the end of this parking stripe. So I can select it, and I can hit done. It gives me the same button, place GCPs on 3 more images. So I select that. Then I can filter by GPS, and it will only give me the images in that area. All right. So again, this is just one other way that you can find what images correlate with what GCPs. So I could go ahead and set that there. I can pick the next image or another image. Pick here. Now I didn't get it right on the end of that stripe, so I could actually move this up. Hit done. And I'll pick one more image. I'll zoom in, and I'll set the point, and I'll say done. Now I've set the 4 for that particular GCP. So I'm not going to set all of these GCPs right here at this particular time because it takes a little bit to add these GCPs. But you can see it doesn't take very much time because we're able to filter things by GPS. We have this nice map that we can go back to that actually shows all of our photogrammetry and our GCPs together so that we can marry up the images to the GCPs, so on and so forth. So I'll go ahead, and I've already got this particular job processed. So I'm going to go ahead and hit done here. We would go ahead and set each GCP just like we set the last 2. All right, so I'd hit done. And at this point, once the GCPs are set, I can go ahead and hit create. Now, one last thing. There are cloud credits that are charged for creating a model and recap photo. So it gives you a breakdown here in the upper right hand corner. For 12 cloud credits, that's the use of 20 to 300 photos. 30 cloud credits are charged if you have 301 to 700 photos, and 55 cloud credits are charged if you have 701 to the 1,000 photo threshold. So most generally, depending on the height that you fly things, you can actually be in this 30 cloud credit range, 301 to 700 photos. That's also going to help reduce the processing time. This particular job, I will tell you, it took about 12 hours to process, but it is right at that 1,000 photo threshold. And we had 23 GCPs. So we got a very good, tight model whenever it got through processing. And we'll show you that in just a second. So all we would do here, I'll go ahead and close that, is hit create. Now when we hit create, we need to give it a project name, and I'll just give it a name here, WP Test GCP. And again, this is just a name, okay? It can be whatever you want. I'll make it all uppercase, GCP. You tell it what you want it to build. So I want it to build the 3D photo textured mesh, the RCM. That is the mesh file. The 3D point cloud, which is the RCS, which it will generate several RCS files that are put together with an RCP and a recap project. And then the ortho photo. Now the last thing, and this is a very key step, you want to be sure to select the target coordinate system. Now, all of these images, as you saw, they were built on lat long. All right, so it's going to take that lat long coordinate, and we need to have it convert it to state plane. Now, the GCPs that we put in were all at MO83-CF, Missouri State Plane, Central Zone US foot. All right, so that's the target coordinate system that we want to build this in. So we just hit our 3-dot button there, or ellipsis, select MO83-CF, and hit OK. This is very key. You want to make sure that you set this, and then hit start. All right, when we hit start, what it does is it comes down here and actually starts to process and push all of the images. So you can see here it says preparing to upload. So it's going to upload all of these images to the cloud, and it's going to do all the heavy lifting of processing inside the cloud. Now, if I had 5 or 6 other projects that I'd flown that I needed to go ahead and process, I could start that process all over. I could hit aerial, I could add the photos. If I had GCPs, I could add the GCPs, so on and so forth, and process that particular job. So I'm going to go ahead. I've already got this job processed. So if I do process something and I want to cancel it, I can just hit the X, and yes, it will cancel that project. Now, what did we get back after it was processed? Well, I'll show you here. In this folder is what we got back. And if I go back to my cloud drive here, this is A360. All right, I could go over here, and this is the job that I'm getting ready to show you. It was processed. To download everything that you're going to see in this folder, I simply hit this button. All right, this downloads directly to whatever folder you want to put it in. All right, and these are large files, so it does take a little bit of time to download the files according to your internet speed, of course. But I have gigabit internet, so my download speed is 1 gigabit, so it takes it about 3 minutes to download. That is also going to be kind of governed by A360, so it'll pull it as fast as A360 will push it. So just want to kind of throw that out there. Because these are large files, and I don't want you to think you can just click it and voila, it's going to be there. It does take just a little bit of time to download. All right, so this is what you get. All right, you get the RCS. All right, so inside that RCS file you have, or folder, you have the RCP mesh. All right, that's what it calls it, is mesh. That's the recap project. And then it has the mesh support files, and these are all the RCS files that make up that project. All right, that's the point cloud. Now, you also get a image, and I've expanded these into here, so you get a mesh DEM and mesh ortho. This mesh ortho is our georeference TIFF. It comes housed inside of this WinZip archive file right here. So you just select it, right click, and extract files, or extract them to here. All right, and this is what you get. So this is your image. All right, then you get this RCM file, which is your recap mesh file. All right, let's look at that mesh file real quick. So if I hit load model, all right, and I go to drone to design, and I get back into that folder. This is the RCM file we wanted to look at. All right, it will open up that mesh file, and you can take a look and see if it actually covered everything that you needed it to cover. You can also see all of the 3D entities. So it's a very, very nice way to look at things. It's a great presentation piece. All right, and you can see there's a lot of great detail from this particular mesh. All right, so I've got areas where they've carved out dirt and rock and things of that nature, and those show up perfectly. And this is all generated from that photogrammetry. Now, this particular file is, you've got the La Quinta here, all right? We've actually got it a little bit better than this particular mesh file because I've added the other facade images, so this would be a much crisper building, all right? We've got this big major retail store here, and so on and so forth. I mean, it just gives you incredible detail, all right? And this is detail that the surveyor just physically cannot pick up in traditional methods of survey. So if we wanted to export this out as a presentation piece, we could export an image, we can export a video, and we can actually export this model in several different formats. We can export it out as an FBX. We can use that FBX inside of InfraWorks to make the models more crisp, make the entities more crisp, things of that nature. So there's a lot of different things that we can do here in Recap Photo. But the next thing that we need to talk about is bringing this information into InfraWorks. So the information that we're going to bring into InfraWorks was exactly what was in that folder. All right, it's in this folder right here. We're going to bring in the RCS file, and we're going to bring in that image and take a look at what it's generated. Now, once we're in InfraWorks, we're going to build a surface from that particular point cloud. So let's jump into InfraWorks and start to import this data. So now here in InfraWorks, we're going to create a model from scratch. We're going to import the point cloud that we generated in Recap Photo from the drone data, and we're going to create a surface from that there in the model. That surface then we will be able to go ahead and bring directly into Civil 3D. So let's start off here in InfraWorks and go ahead and create a model for this area in Model Builder. So if I select Model Builder, you'll see that I like to have an actual polygon that creates my AOI, my area of interest. So you could actually, if you know the exact area, you could actually zoom into it. I'm just going to use the AOI again so I know I'm exactly where I need to be. So I'm going to select that button, and I'm going to use this boundary that I created from Civil 3D. So I'll just select the shape and the PRJ file, and it brings me directly to where I need to be. So I can turn on the aerial here, and I can see that that is all of my area. All right, so I'm going to go ahead and call this Drone to Design Use Case. All right, and I need to be sure that I select the correct location for storage in BIM 360. Now, I have a JS folder here, and I'll show you right here. JS scan to BIM use case. I'm just going to select project files, and I have an InfraWorks model folder in here. So I'm just going to select that, and I'm going to select create model. And it's going to generate the model from Model Builder. All right, so we can see that it has populated here on the home page in InfraWorks. So I can go ahead and close my Model Builder page, and I'll select that particular model that it just generated. And we're going to start off by bringing in that what is there today image. I like to call it that because we have flown it, and you could actually fly things daily if you'd like, because things can definitely change on the ground, especially in construction, from day to day. So I like to call it the what is there today image. It's going to be a much more up-to-date image than anything from Bing or from Google Earth or anything like that. So that's why I call it the what is there today image. All right, so we have our model, and you can see that the image actually is going to look pretty close to what our what is there today image does, but this our what is there today image, or our georeference TIFF, will actually show in greater detail. So you can zoom in and you can see that things are real fuzzy here around this retail store. This is where that hotel was, the La Quinta, and I guarantee you it's going to look a lot better when we bring that image in. So let's do just that, but first let's create a new proposal. So I'm going to select master here under proposals, and I'm going to select add, and we're just going to call this with image. I'll hit OK. While that's generating the proposal, I'll show you this is the ortho that we're going to bring in. Now again, this is the set of data that we downloaded from Recap Photo after it got through processing. So we have the TIFF file here that's in a zip. So all I have to do is right click and hit extract files here, and this is what it gives me, the mesh DEM and the mesh ortho. So now that our proposal is generated, I can go ahead and select that mesh ortho file, and I'll do it here, mesh ortho file, and I'll drop it on the screen. All right. So there's another step that I want to show you. Sometimes I go ahead and hit close and refresh, but what's going to happen is it's going to give us a black band around the outside. All right, so I'm going to go ahead and take care of that right here out of the gate. So if I select raster and color mask, then I can select that black color that band would be and hit OK, and then just hit close and refresh, and it will refresh the image without the black band. All right, so we can zoom in and take a look at that image, and we can see that it is a much finer image. All right, I can zoom in and see the rocks on the ground. All right, I could zoom in and see the parking stripes much, much clearer than what I could in the other image. I'll zoom in here to this parking lot. Notice that it is much, much cleaner. You can really see the difference over here on the back side of the loading areas because you can read what's on the ground, flatbed unloading zone. So you definitely want to take advantage of that image. Now let's drag and drop in the point cloud. Now I'm going to create another proposal. I'm going to call it with image and surface. Now this is totally up to you. I just like to keep things separated out to where if I'm in a proposal and it starts to lag just a little bit because this image or this particular surface is going to be pretty big, I can always go back if I want to just see just the image and not have the surface in that proposal. InfraWorks will run a little bit faster. Not that it's going to run slow with the surface, but it will perform a little bit better. So I always create another proposal. And again, that's personal preference. We could have imported it in to the master if we wanted to. It's just good to keep things separated. All right, so I'm going to drag that point cloud over. So if I look here in my Windows Explorer, I've got this RCS folder. Now that RCS folder came from this archive right here, this WinZip archive. I just right-clicked on it and hit extract here. Now I'm going to double-click on that RCS, and it's called mesh.rcp. So it's a recap project. It's made up, again, of all of these RCS files that it generated in recap photo from the drone photogrammetry. So I'm going to grab that mesh file and drag it onto my screen. One thing we need to be sure of here whenever it does connect is that it is in the right coordinate system. If it shows up here and it says something like XY-M or a coordinate system that is not actually in, or it should be in, we know that we have a problem right out of the gate. All right. So if it does come in though, and it does say something like that, see if you can change it to that coordinate system and go ahead and close and refresh, and it maybe come in the right spot. I have seen to where that does happen at times, but 99.9% of the time you should see the coordinate system that you are wanting to bring it into. So just hit close and refresh, and the point cloud will come in and populate. All right, and it does take it just a second to populate. Now we're going to be able to see some of the point cloud, and some of the point cloud we won't, because the cloud is actually at the correct elevations, and it's still seeing the InfraWorks surface here. It's not generated a surface from the point cloud yet, so some of this cloud will actually be underneath the InfraWorks surface, which that's okay. That's pretty typical. All right, so you can see here, if I turn it on its side, we can see the trees, things of that nature from the cloud itself. So again, some of this surface or some of this point cloud is actually underneath the InfraWorks surface, which is normal. All right, when we generate the surface from this point cloud, then you'll be able to see all of the point cloud itself. All right, so let's go ahead and I'll zoom back, and I'm going to create a surface from this point cloud. So if we go back up here to our InfraWorks button and select Create and Manage Your Model, we can go down to Point Cloud Terrain. All right, in this particular instance, well, in every instance, you'll see in the selected datasets area, you'll see the name of your point cloud. Now, if you have multiple point clouds, you will see all of those point clouds here in this selected dataset. So what we can do is we're going to leave this all optimum for right now, and we're just going to go ahead and hit Start Process. And it will generate the surface from our point cloud. Now that the surface has been generated, we can actually zoom in here and we can see all of the point cloud, and we can see all of the vertical features that were showing up inside of that point cloud. So you can see this rock cutout. We can also go from a conceptual view to an engineering view, and we can take a look at the contours and see how they represent the surface from the point cloud. So you can definitely see that it is taking into account for this cutout in the rock. Also, if I zoom over here to these detention areas, you can definitely see that it is taking into account for those. And the closer that we zoom in, the tighter that the contours get. So I'll go back to a conceptual view. One last thing before we jump into Civil 3D and import this surface from the InfraWorks model is I'm going to zoom in, and I can see some good detail here, but if I go over and turn on my Model Explorer and turn off this 2D mesh, right, I can definitely see better detail from that. So this is great for presentations, being able to show relief, show the terrain inside of the model. And as you can see, it does a very, very nice job. So let's jump into Civil 3D and bring this surface in so that we could maybe possibly start some design. So before we jump into Civil 3D, we want to sync this model with BIM 360. Whenever we created this model in Model Builder, we had a project folder that we created inside of BIM 360. If I look here in Google Chrome, I can see here that I'm in my folder here, my JS Scan to BIM use case folder, and I can see my model here. Now, one thing I want to point out is that it is V2, so it has been synced once, but we've made changes to the model, so we want to be sure that we have those changes pushed all the way through to BIM 360, and so that we have a backup of our model if something was to happen to our local copy. So here in InfraWorks, I want to just simply go up and select the Sync Model Changes with InfraWorks. All right, it's going to check the model, and it's going to connect to BIM 360 and compare the models that are on our local machine and in BIM 360. We can see that we do have changes here. So I'm going to go ahead and select Sync, and it's going to sync my model to BIM 360. So once the model is completely synced to BIM 360, it will tell us here that it has been synchronized. We can hit close, and then if you go back to BIM 360 here in Google Chrome, you can see that it is regenerating. When you have this circle here that's rotating, that means that it's being regenerated. So it's going to take just a little bit for it to regenerate inside of BIM 360 in order for us to go ahead and select it and start to look at it here in an internet browser. So you can also see that it has changed the version to version 3. So we'll wait for it to go ahead and update this version, and then we'll take a look at the model inside of BIM 360. Now that our model has been synced, and you can see that it says version 3 here. So we started off with version 2, we synced it in InfraWorks, and now that it has been synced with BIM 360, it says V3. So this is the most up-to-date version of our model. Now if I select that model here in BIM 360, I can open it up, and I can see that it starts out in the master proposal. So I don't see my imagery, I don't see my surface. So if I spin around here and I look, I can see that this is still using the USGS contours here, where we've been kind of focusing on inside of this workflow. So to change the proposal, I can go over here to the left-hand side of my web browser, and I can drop down to Sheets and Views. So once I select Sheets and Views, I can select Image and Surface, and that's going to be the model with my surface and image that we saw back here in InfraWorks. So if I was to come back, I could zoom around and I could show you that same location. I'll go back to my model here. It does take a minute for it to load. It's quite a bit of data for it to load. I'll go ahead and turn it on its side here. And I can see that it mimics what is there in InfraWorks. Now, I'll go ahead and close my Sheets and Views. A couple of things we can do. Inside of BIM 360, it's using the Autodesk viewer. So, and I'm using Google Chrome that you see here for my internet browser. So, some things we can do, we can zoom in with our wheel, and that allows us to zoom. We can hold our left mouse click down and we can spin the model. We can also hold our right click down and we can pan around inside the model. So I'm going to zoom up here and show you how we can actually flip into what they call a first-person view. So if I select first-person view, I can just hit OK. It's just telling me my navigation for walking, going up and down, running, so on and so forth. So we'll remember the arrow keys, or WASD, and Shift and then a direction key will let me run. So I'll go ahead and hit OK, and it brings me down and sets me on my surface. All right, so I can tilt the screen here a little bit so that I can move, and I can use my arrow key, and that will allow me to move as if I'm standing on the surface. Now remember, if I hold Shift and my arrow, then I can actually run. So I could take a look in what they call a first-person view of this area. So I could continue to arrow around and look at things in a first-person view. Now remember, it is going to follow the surface, so whenever I get to that area where there's like that shear wall cut right there, then it is going to just drop down the surface. So if I select back out of that first-person view, I can scroll back, and I'm back to my regular navigation. I can also measure some things. So I'm going to go ahead and select Measure, and I'm going to pick a point here, and then drag and pick a point here. All right, so I can measure the distance on that cut slope that's right there, that shear wall of rock. Now, it's given it to me in meters. It's given me the distance in meters. And it's giving me the X and Y in meters. So I want to change it here with my measurement settings to feet. Actually, let's just use decimal feet. And I can take that out to 2 decimal places if I would like. And I can hit done. All right, when you hit done, it gets rid of your measurement. So I want that back. So I'm going to measure again. And it's measuring 33.76 feet. So how does that look inside of InfraWorks? So if I do the same thing here in InfraWorks, and we're not going to be able to hit the exact same location, but I can go back over here to my Analyze Your Model tab, and I can drop down and I can select 2D distance and slope, or I could pick point-to-point distance. All right, so let's pick 2D distance, and I'll just pick this point here, and I'll pick right there. And you can see when I zoom in, I didn't pick the exact same location, but it says 32.8 feet. All right, if I flip back, I'm at 33.76. So it is reading the surface correctly directly from InfraWorks, but I'm looking at it here in Google Chrome. All right, I'll go ahead and hit done. A couple other things we can do. We can do some markups. So if I was to want to collaborate with someone and tell them, hey, I'd like for you to maybe run an earthwork in this area, I can select Add New Markup, and I can put a rectangle around this area. All right, just put a rectangle around it, and then I could put some text in. So I'll put some text here. Please run an earthwork on this area. All right, and I can actually just hit enter, and it will move down actually, and I can hit done, and this is in a markup view. So once I exit that markup view, it goes away. Now, where did it go? Well, I want to be able to see those markups. Over here on the left, I've got markups, issues, sheet views, and history. So I can select markups, and then I can pick that markup right there. All right? And it tells me need earthwork in this area. Now, I've done a markup before, and again, actually this is the current one. It says please run an earthwork on this area, and the V2 would be the markup that I did before. So you can add those markups to your model, and then you can send those out. So you can publish those, or we can have those published. I'll go ahead and select published. So you're about to publish a private markup, and will be seen by all project members. So anybody that's assigned to this project will be able to see it. So I can hit publish, and it will publish that particular markup for everyone that's collaborating to see. So I'll hit exit markup view, and a couple other things here I'll show you. We can look at the model browser. We don't have that many objects or that many different types of objects inside of our model here. We've got some roads, we've got our surface obviously, and we've got our images. So I can turn that information off. It works much like the layer controls inside of Civil 3D or InfraWorks. So I can select my buildings, turn them off. I think I've only got one building in here, but I can turn my roads off, and you can see that the roads will go away. I can also turn the terrain off, and my terrain is going to go away. And if I turn this on its side here, the terrain actually looks like it's still there, but the actual imagery and everything that's draped on top of it goes off. So I can turn that back on with the click of a button inside of my model browser. So I can go ahead if I want, and I can also check on properties inside of the model on specific things that have information on them or that can be selected. So I can select the road here, and then I can select properties, and it gives me all the information on that road. Now this road was brought in from InfraWorks, so it's got all the information that would typically be on there from an InfraWorks model. All right, so I can close that, and I can hit escape. Now if I select the surface and then hit properties, I don't have any property data or anything on there for this surface, so it's not going to show anything for that specific terrain. But if you have other information in here, like there's this building that we have, it'll actually give me the information that's on that building that came in from InfraWorks. So great information here, and just shows you that you can actually list the properties and things of that nature of the model. So last thing I'll show you here, we can actually use this in a full screen mode, and it gets rid of any unused space, and it allows you to see more of the model at one time. All right, and to get that back to back out of full screen mode, then we just hit the same button. So now that we have everything synced up to BIM 360, now we can go ahead and open Civil 3D and start to use some of this data for design. Now that we're going to be moving into Civil 3D, we've generated the surface from the point cloud that we generated in Recap Photo from our drone photogrammetry. And we are done with InfraWorks for right now, so we need to close InfraWorks in order to attach to the model inside of Civil 3D. So the first thing we do in Civil 3D, as always, is we need to make sure that our coordinate system is set correctly. So I'll go ahead and type in the coordinate system here, MO83-CF, and I'll hit apply and OK. And I want to go ahead and I want to save the drawing. All right, so I'll save this drawing in my Civil 3D folder, and we'll just call this D2D surface. You can name it whatever you would like. All right, once our drawing is saved, we're going to go up to our Autodesk InfraWorks tab in our ribbon and select Open Model. Now, again, you want to be sure that your InfraWorks model has closed. so that we can attach to it and it will perform correctly. If you attach to a model too soon before it's kicked it out of memory, or if it is still open, then what will happen is you'll get an error here. So I want to go ahead and attach to that model. So I'll go ahead and select the database or the SQLite database of the model in InfraWorks, and it will attach with no errors. Now I'm going to go through and make sure if I wanted to just bring in just an area of interest, I could just select area of interest and then hit select area, and it would show me the entire model, and I could just select an area out of it to import. But I want to bring in the extents of the InfraWorks model. The one thing I do want to do is just refine the selection set from that model itself. And this is because I don't necessarily need the roads. I could bring them in, but I don't necessarily need them. So I can actually select what I want to bring in. As you can see, the planning roads here need to be turned off because I don't want to bring those into the model. So I'm going to go ahead and check those off. I could actually collapse the asset tree and then take the check marks completely out of everything because I'm really only concerned with one surface, and that's this existing ground surface. So I'll check it, hit OK, and then hit Open Model. And the surface comes right in. Now this particular surface does have a little bit of the InfraWorks surface merged in with it. So what I can do is I can actually bring in the image that was generated also in Recap Photo, and we'll be able to build a border around where our surface was generated from the point cloud. There's a couple different ways that I could do this. I could actually attach it through map. So I could type map W space and turn on my task pane, and I could actually add it in as a data source. So I could select here, add raster image or surface, and I could connect to it here, just connecting to the source. But today what I'm going to do is I'm going to actually insert it using raster tools or raster design in the AEC collection. I'll just select insert, and I will navigate out to where our folder was for our data set, and I'll select the mesh ortho and hit open. Raster design will then read in the image and transform it into the correct coordinate system, which is Mo83-CF. So you can see we're going to be able to chop off quite a bit of this surface by using a border. So I'm just going to hit next here, next, and this is where you want to make sure that the transform coordinate system is selected. So it's going to transform from the WGS84 coordinate system into our state plane coordinate system. And I'll hit next and finish. And it will bring that image in its correct location. Now that our image has come into Civil 3D, we can go ahead and just create a polyline around the outside of our image, just manually, and we can take it as far as we want to go. I mean, we can come inside the image. We basically just want to make it to where the extents of the image are, just so that we can be sure that we're just using the point cloud for the topo. So I'm just going to jump around here real quick, create a boundary so that we can apply this to that particular surface. Come back up here. And I'll close it. And then we will go over to our existing ground surface, and we will add that polyline as an outer boundary. Now everything that you see should be contour information that was generated from the point cloud. So if I go into the surface style, I can change the colors here real quick to something a little brighter so you can see it. Say maybe red for the majors and white for the minors. You can see that we've got a high level of detail, and we are taking into account again for the rock here. I keep coming back and showing that, but it does definitely show great definition here. See the detention pond areas and things of that nature. So last thing we'll do is we'll bring in the actual control that we shot in the field for our GCPs. So if you remember, we used those GCPs when we created the point clouds in Recap Photo and actually processed the imagery and applied the GCPs to them. And it was this GCPs file. So if I double click on that, you can see it as a point number, easting, northing, and Z elevation. So what we'll do is we will just import that particular file. I'll go out and grab it here in the GCPs folder. All right, and I'll select the correct format. So this is PENZ, comma delimited. And we'll go ahead and add it to a point group called GCP and hit OK. I'm going to change the annotation scale to, say, 1 to 100 so that we can see them just a little bit better. So let's zoom in here and take a look. Just take a look at a few here. 928.73 and 928.93. I can get a little closer here to it. 929, so it's about 0.2 off, 0.25 off. All right. Vertically, but it hits really, really close horizontally. I'll measure and see how close horizontally we got. It's 0.3. Let's go back over here on this side and we'll check this point. 919.42 and 919.45, so we're around 0.13 hundredths of a foot different. Check this manhole lid. 948.43 and we're at 948.60 was the GCP. So it's pretty consistent. We'll go down here and take a look. Let's check this one here. 1032 or 1039.62 and 1039.36. So about a little over 0.2 feet off vertically. So on 200 acres, we had around 22 GCPs. Probably could have used a few more, but you can see that we got pretty close vertically to the ground control points. And I can tell you that the vertical accuracy and the amount of data that we have is much greater than what it would be traditionally. And I go back to this area here where you can see the rock walls that we showed earlier in the mesh file. And the detail, the amount of detail that we have in here is just fantastic. So now we're ready to start laying out things preliminarily, or we can go straight into design if we're comfortable with the elevation differences, which 2/10 is not that bad over 200 acres, and we checked several of the GCPs, so we're that close on the ones that we checked. So, and horizontally, the image comes right in almost exact. So that is the drone to design part of Scan to BIM. I hope you enjoyed the series of videos. Thanks and have a great day.